Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at how we can use Venn diagrams and two-way tables to solve problems involving conditional probability. So please look at my video on Venn diagrams and two-way tables if you're not sure what these things are. So because we're using conditional probability, I'll write the formula. The probability of A given B, so we're saying B has happened. What's the probability A also happens? It's the probability of A and B over the probability of B. So remember, whichever is listed second here goes on the bottom. So how might we use Venn diagrams and two-way tables to solve problems here? Well, remember, we use Venn diagrams and two-way tables when the question involves more than one set. So let's look at such an example. So let's try this question here. 200 year 11 students, 95 of them have blue eyes, 20 have blonde hair, and 99 have neither. So if a student is selected at random, we're going to find the probability they have blue eyes given that they have blonde hair, and blonde hair given that they have blue eyes. So this question involves two sets, people with blue eyes, people with blonde hair. So two-way table of Venn diagram would be appropriate. I'm going to use a Venn diagram for this, but a two-way table would be just as effective. So what I'm going to do here is I'm going to have one set be blue eyes and one's the set of people with blonde hair. So as I alluded to in a previous video, if I add up all these, 95 plus 20 plus 99, I get 214, and I said however many you've overcounted, that's how many are in both. The only way all of these can add up to 214 when there's only 200 students is if I've counted 14 of those students in the blue eye category and the blonde hair category. So I'm going to put 14 here that go in both. So I'm told that 95 have blue eyes. So I've already got 14 in the blue-eyed circle, so I need 81 here. Similarly, I need 6 more for the blonde hair circle and then 99 outside. So note all of these four numbers inside the Venn diagram, they add to 200. So I know I'm doing something right. So now let's look at this question. What's the probability they have blue eyes given that they have blonde hair? So I'm saying I know I'm in the blonde hair circle. What's the probability I'm also in the blue-eyed circle? So that's actually really simple. There are 20 possibilities inside the blonde hair circle. 14 of them are also in the blue-eyed circle. So you can go 14 over 20, which is 0.7, or 7 over 10. So I could also use the formula here. I would have got the same answer. So the probability of blue eyes and blonde hair is 14 over 200. The probability of just blonde hair is 20 over 200. And if I put this on my calculator, I get the exact same answer of 0.7. So what about the probability that they have blonde hair given that they have blue eyes? Well, this time, I'm saying I know I'm in the blue eyes circle. What's the probability I'm also in the blonde hair circle? So this time, it's 14 out of 95. Again, I could have got that using the formula here. The probability of blonde hair and blue eyes is 14 over 200, as it was before. The probability of blue eyes is 95 over 200. So either way, you get the answer. I don't mind. All right, let's look at a slightly harder question now. So let's try this question here. Year 11 students asked whether they play soccer, AFL, both or neither. 25% play soccer. Of those, 12% also play AFL. We also know 58% of students play neither sport. And we want to know if we select a student at random, what's the probability they play soccer given they play AFL? What's the probability they play soccer given they do not play AFL? So again, I'm talking two sets. People who play soccer, people who play AFL. So we should be thinking Venn diagram or two-way table. Now, a two-way table is going to be much easier here. The reason is I'm given information about the total. 25% in total play soccer. That's not 25% who play soccer and AFL. So because I'm talking totals, two-way tables are easier to use because remember, they have a row and column for totals, whereas there's nowhere to write the total in a Venn diagram. So remember, we set up our two-way table like this. So the two ways, we can have people who play AFL or not AFL, and soccer or not soccer. And then, as I said, we have the row and column for total. So because we're talking percents, everything should add up to 100%. So I was told that 25% play soccer. So it goes here. Again, it didn't say 25% play soccer and AFL, which would be the number here, or 25% play soccer and not AFL. That's why I put it here. It's just 25% of the total play soccer. So we also know 58% play neither. So the neither is over here. Now, the other bit of information we need, of the people who play soccer, 12% of them also play AFL. So what goes here is 12% of 25%. So if you do 0.12 times 25, you get 3. 12% of 25% gives us 3%. That means 3% of all students play both. Again, that's 12% of 25%. So we can fill in the rest of the numbers pretty easily. We know that 22% will go here because it has to add up to 25. We know this will be 80, 22 plus 58. So we have 20, 17, and of course this should add up to 75, which it does. Okay, so everything adds up to 100%. We know we've done something right. Getting this two-way table is the hard part. Now the easy part, what's the probability they play soccer given that they play AFL? So if they play AFL, I know that I'm in this column here. So of the people who play AFL, 3% of them play soccer. The probability someone plays soccer and AFL is 3%. The probability that they play AFL only is 20%. So it's just 3 over 20, which is 0.15. That is the probability they play AFL given that they play soccer. So the probability they do not play AFL given they play soccer, well, it's very similar. Here we're in this column. So the probability of both, the probability someone plays soccer and does not play AFL is 22%. The probability someone does not play AFL is 80%. So it's just 22 over 80 or 11 over 40 if you like 0.275. How easy is that? All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.